Right, so we're looking at the rules for questions 11 to 17, okay? It says that a cruise line is scheduling 7-week-long voyages for the ship A. Now, I don't want to take the effort of looking at these names in here because names are kind of hard, they're long, makes life tougher. Let's just refer to things by their first alphabet, okay? So then you don't have to waste time and effort in, knowing the pronunciation of these names, okay? Moving ahead, it says that each voyage will occur in exactly one of the first 7 weeks of the season, weeks 1 to 7. It says each voyage will be at exactly one of 4 destinations, okay? And it gives you 4 destinations. They're G, J, M, and T. You see, it wastes no time, okay? And then it says each destination will be scheduled for at least one of the weeks, okay? And then it says that the following rules, conditions apply to A's schedule. Now, let's try to draw the diagram first before we go and look at the rules. Now it says that you have 7 week-long voyages. That means you have 7 voyages, okay? And you have 7 weeks from 1 to 7, okay? So what that means is that, let us say these are our weeks, okay? 1, 2, 3, 4, 5, 6, and 7. I put the name 1, 2, 3, 4, 5, 6, and 7. If you have 7 voyages in 7 weeks, right? It means that none of these is empty. So you can't say that, hey, nothing's happening on 2. You can't say that. Definitely you're going to have something in each one of these, okay? That's the first important thing. The second thing is that you have only 4 destinations, okay? Now, you need to ensure that you have at least one of them on each. For example, you need to ensure that there's at least one G, at least one J, at least one M, and at least one T. But you might have more of them. For example, you might have maybe 3 G's, or you may have 2 J's and 2 G's and so on. But you cannot have a case when maybe there's no M in here. That's not possible. You need to ensure that each one of them is there, okay? Each one of the 4 destinations is there, okay? So we have the diagram with us now. Let us go ahead and look at the rules and enter them into the diagram that we have with us as of now, okay? Let us start with the first rule. The first rule says that J will not be its destination in week 4. So it means that let's say we put it down on 4, that whatever is not going to happen, we put it down. So J is not going to be a destination on week 4. Let's look at the second rule. It says T will be the destination in week 7. Okay, so let me just put that in here. So you know that you'll be having T on week 7. Then it says that A will make 2 voyages to M, and at least 1 voyage to G will occur in some week between those 2 voyages. So what that means is that it doesn't tell you when, it doesn't give you week 1, 2, 3, it doesn't tell you that. What it tells you is that, hey, there are going to be 2 trips to M, 2 voyages to M, so this is an M and this is an M, and sometime in between that, you will have the G, okay? So let me just have this diagram with me, that you know that this is going to happen, okay? There's going to be at least 1 voyage to G in between the 2 M's, okay? Let's look at the next rule. It says that G will be its destination in the week preceding any voyage it makes to J. So it says that whenever there is a J, okay, let's say there's a J, then in the week preceding that, there will be a G. Now, an important thing for you to remember here is that this is not the same as saying that whenever there is a G, there will be a J in the next week. That's not what this is, okay? So remember that all this is telling you is that whenever there is a J, you know that in the preceding week, which means the week before that, okay, exactly the one before that, no gap, right? So for example, if J is in week 6, if J is in week 6, then you know that G will be in week 5, okay? But that does not mean that if G is in week 5, then J is in week 6, okay? Just remember that. Let's look at the last rule now. It says that no destination will be scheduled for consecutive weeks. Oh, so in the beginning I kind of drew a diagram where I said something like G, G. Hey, that cannot happen because you cannot have the same thing on consecutive weeks, okay? So nothing can be consecutive. You cannot have an M and an M, for example. So for example, you know that this cannot be a T because you have a T in here. So you can even put that down here for the time being. Let's just put that in here. So you know that because you have a T here, you cannot put a T on position 6 again. Okay? So now we have the diagram. All of these rules have been put into a diagram. And now we can use this diagram to solve the questions one by one. The first question of the set, question number 11. Let's first get back the diagram and now read the question. It says, which one of the following is an acceptable schedule of destinations for A in order from week 1 to week 7? Now, what that tells you is that you have 4 options here, okay? And only one of them is acceptable. Okay, so one of these 4 options is acceptable and 3 of these 4 options are not acceptable. What does that mean? That 3 of these do not follow the rules, which means that they do not follow what we just put in here, okay? So let us go through the options one by one and see as to which one follow the rules, which one do not follow the rules, and we'll pick our answer. There's only one that follows the rules, okay? So let's start with option A. Does option A follow the rules? Look, so you have G in here, okay? Then you have J. So you can find that there's a J and a G. Looks good. Okay, then you have an M and you have an M. So if you look at this rule here, you can find that there's a G between an M. Okay, that also works okay. Looks fine. You're supposed to not have anything consecutive. You don't want a J on the 4th. That's also fine. So this looks like it's following all the rules, okay? So to me, as of now, 1A looks like the answer. Maybe I might have missed out something. So let me just look at the other options. If I find that the other options are wrong, then A is the answer. You know, that's my way of checking whether I was careful enough or not, okay? Let me just look at the other options. If I find that, hey, B is also working, it means I need to go back and look at A once again, right? I'm just letting you know the procedure that I follow. Okay, well, let's look at option B. It says G, M, T, M, G, J, and T. Okay, now you cannot have J on 4, so that's okay. You need to have an MGM. You see here there is no MGM pattern. You don't have a G between the M's, so that's gone. That's wrong. Okay, let me just take this off. So you know that B is not the answer. Let's look at option C. It says J, M, G, M, G, J, and T. Okay, so do you have a G before a J? Yes, you do. Here. But what about here? What about here? If you look at the first one, you're supposed to have a J, a G before the J. Okay, whenever there is a J, there has to be a G before it, which means J cannot be in the first spot, right? And therefore you can see here, although you have the MGM with you, you have the T in place, you have this, but the first option cannot, the first voyage cannot be a J because, hey, where you put the G before that? You can't put it, right? So it does not follow the rules. So I need to take this off so we know that C is also not the answer. Let's look at the next one, option D. It goes M, T, G, J. Oh, it has J in 4. Not allowed. So D is also not the answer. So you know that A is the answer. Let's move ahead. Question number 12. Here's the diagram. It says, which one of the following cannot be true about A's schedule of voyages? What that means is that, hey, once again, you have 4 options in here, okay? So out of these 4 options, one cannot be true, okay? And the other 3 can be true. Now, what is the meaning of something can be true? It means it could be true or could be false, okay? So this could be true, or it could be false, okay? That's what it means. But one of these cannot be true, which means that it is always false, okay? Now let's look at the options one by one and see which one of these is always false, okay? So if you can find that something is sometimes true, well, then that's not the answer, okay? So you're looking for the option, the answer, right? The answer is the one that cannot be true and that is always false, okay? So let's look at option A. A makes a voyage to T in week 6. Hey, we just saw that this cannot be true, right? We just put that in here so we know that A, this is the answer, okay? Simple question. If you try the other 3 options, you'd find that they're possible. Let's quickly try them out, okay? So you know that A is the right answer because it's not possible. But still, let's look at the other options. Look at option B. B says that A makes a voyage to M in week 5. Is M possible in here? Of course, looks okay. Look at option C. A goes to J in week 6. Yes, indeed, you can put J in here, no problem. Look at D. It says A makes a voyage to J in week 3. This can also happen. So A is the answer because this is the one that has to be false. This is always false. Whereas these could be true, right? So therefore, they are not the answers. Let us move ahead. Question number 13. Right, question number 13. So here is the diagram, and let us read the question together. It says that if A makes a voyage to T in week 5, then which one of the following could be true? So once again, before you look at the options, this means, the question means that one of these could be true, and the other 3 options, right, out of these 4 options, one of them could be true and the other are always false, right? Remember that something that could be true could be false as well, okay? So the problem is not that something could be false, because something which could be true could be false. But when you're saying that only one of them could be true, it means that the other 3 are always false, so it cannot be true. So it's not possible. It could not, or rather when that becomes, when you write it again, it cannot be true, right? So that means it is always false, okay? So now that you understood this, let us look at the options and work on them, okay? So let us say we put in the T on position week number 5, because that's what it says, T in week number 5. Just a moment, let me just put that in. Okay, so I put in T in here, week number 5, that's what it is, Trinidad in week number 5, put that in. Okay, T in week 5. Then it says, which one of the following could be true? Let's see if, hey, can A be true? Let's try it out. So the option A says that there is a voyage to T in week 1. Okay, let me put that in. So let's say I use a green pen for what I add. Okay, so it says that if for the options, right? So A goes to T in week 1. Now, if A goes to T in week 1, where do you put this MGM? Like, where do you put this? Can you put this here? Okay, you put it in here. Then where do you put this? Like, you can't put this in here. So you can see that you are not in a position to follow these rules, right? You can't follow these rules when you are in this arrangement. So the moment you put T in position 1, you cannot follow the rules. So it's not possible, which means that this is always going to be false. This is like an always false statement. So you know that A is not the answer, okay? Let's look at option B. Okay, let's see if we can, if B is possible, let's just look at it, okay? It says that B says that it makes a voyage to M in week 2, so let me just put M here. Okay, let us say we have M here, and I now want to accommodate all of these rules, okay? I want to accommodate all of these rules. Now, I can put a G in, where can I put the J and the G? Can I put the J and the G in here? Like, can I do this? Oh no, I cannot because J is not allowed here. Okay, I can't do that. Then what can I do? Where can I put J and G? Well, there's no place I can put it. So you come to know that even B is not possible. So B is also something that is always false. Okay, so B is also always false. Let us look at option C. Option C says that A makes a voyage to G in week 3. So let's put that in. Okay, let's put G in week 3 and let's see if this can work out. Once again, same problem. If you have the G here, where do you put this? Can you put this here? Well, if you put that here, let's say you put in the J, the G and the J here, where do you put the M that is supposed to be around the G's? You can't, the G, you can't do that, right? So again, this is also not possible. So you know that C is also not the answer. So as of now, even before I've tried, I like to believe that D is the answer, but let's just try it out. Let's see if that can work. Let's put M in position 4, right? Let's put M in position 4. Okay, you have M here. Then because you need to have the G and the JG, let's kind of put an M here. Let's put the J here and a G here. And you can put anything in here. You can put a G if you want here. Okay, as you can see, this is completely okay, which means that this could be true, and so D is the answer. Question number 14. Alright, let's have our diagram again. Now, the question reads that if A makes a voyage to G in week 1, okay, let me write that down. You go to G in week 1, and then it says that it makes a trip to a voyage to J in week 5. Let me write that down as well. So you have J in week 5. Then which one of the following must be true? Okay, now before you look at the options, right, we'll spend some time seeing as to what can be done when we have these two additional rules, so to speak, okay? Now, let's look at this diagram here. Let's just focus on the diagram and then we'll look at the options once we're done with that, okay? So, you know that you need to have this GJ cluster, so to speak, this group somewhere in between. That cannot be here. It has to be either here, or you can put the G here, or you can put the J here. So you know there are various possibilities for this cluster. Let me show you once again. So for example, if you want to have the G and the J cluster, the first possibility is that you can have the G here and the J here. That's the first possibility. The second possibility is that you can have the G here and the J here, like this is the second possibility. The third possibility is that, well, there's no other possibility. Actually, if you put the J here and put a G here, then the problem with that would be that you'd have two consecutive G's, which is not possible. So you basically have two possibilities for the J and the G. The first one is that you have the G and the J, right? You have the J here. That's the first possibility. The second is that you have it here, okay? Now, either way, you need to know that you have to have an M around the G, right? You want an M and then you want the G, right? There's something in between, and then there's the M and the M around the G. Now let us say if you had maybe the first possibility, let me remove the second one. If we had the first possibility, then we need to have the M here, right? And you need to have a G here and an M here. That's one way of going about it. Or in the second case, if we didn't have this, let us say we had only this, okay, you had the J and the G in here, then maybe you could have had the M here and an M here. So you don't know as to where exactly this M will be. But you know for sure that regardless of the case, you will need to have an M in the sixth position, right? Because when you have an M in the sixth position, that is when you can have this criterion to be fulfilled, right? You can have this M, G, M fulfilled only when you have M in position 6. So it's quite clear that the answer to question number 14 is B, because it says that M in week 6. Question number 15. Okay, it says that if A makes a voyage to G in week 1, let me just write that down. You have G in week 1 and T in week 2. Let me put that down too. And T in week 2, then which one of the following must be true? Now, once again, let us see where we can put this cluster here of G and J. Can you put it here? Can you put a G and a J here? No, you can, because you can't put the J here, okay? So that's not possible. Can we put it here? Can we put it here? Okay, let me try that. If you can put it in here, then let's put G here, we put J here, and then we put the MGM, so we put an M here and an M here. So this works. Now, is it possible for us to do that in any other way? No, because let's say, for example, just let me say that, let's say if I had put G and J here, let's say I'd done this, then where will you put the M? You put the M, the two M's together? Of course not. So you know that the only way this can work out is in this way, okay? So we have the entire diagram with us. Now once we have this, it's pretty easy to pick out the answer, okay? Let's look at the options. Which one must be true? Look at option A. It says that M in week 3, you can see that in here. It looks like the right answer. But let's look at the other options too. Option B, it says M in week 4. No, wrong. You have G here, as you can see. So it's not B. B is not the answer. Look at C. It says M in week 5. Well, no, it's a J in week 5. Okay, look at option D. It says G in week 3. No, it's an M in week 3, so it's not even D. So the answer to the question is A. Question number 16. If A makes a voyage to M in week 3, let me write that down here. M in week 3. Which one of the following could be a list of A's destinations in week 4 and 5 respectively? Okay, so now you have 4 options, okay? And out of these 4 options, only one of them could be an accurate list, which means that out of these four, only one could be possible, and the other three cannot be possible. Okay, so let's just try to fit these in here one by one for 4 and 5. Okay, and you'd find that only one of them could be possible and three of them are not possible. Okay, so let's try fitting in these one by one. Let's start with option A. Okay, let's see if it works out. Let's take option A. So we put G and T. Let me put G and T in here. G and T. Now does this work? For this to work, you'd have to have also the J and G cluster and the MGM pattern. Now, if you want to use the J and G, if you want to use this, there's only one place you can put that. You can put it here, right? Because there's only one spot here. So the only place you can put that is here. So let's put that and see if it works. If I put a G here and I put a J here, and then you have this here, maybe I put the second M. So as you can see, I get the MGM pattern here. So because you have the M, the G, and the M, this works. You have the J and the G, this also works. Hey, so A is working out, right? So A is a possible right answer. So according to me, A is the right answer, but we look at the other options too. But as of now, A is the right answer because you put G and T in here, right? You put G and T as is given in option A, and it turned out to be okay, right? Let us look at option B. It says J and G. Okay, so you know that, you have an M here, and then it says J and G in 4 and 5. Let me put them, J and G. Now you know that you cannot have a J on the fourth, so B is not the right answer. Let's ignore it. Let us look at the next option, C. It says M and T. When I put M and T here, you realize that, hey, you have two consecutive M's, and that is not allowed. So you know that even C is not the answer. So C is not the answer. Look at D. It says T and J. Let me put T and J in here. Right. Now, where do you put this J and G combination? Can you put that here? No, you can't. Can you put it here? Well, let's put it. Now, do you see the problem? When you put the J and the G here, you have to put the second M here. But as you can see that between these two M's, there is no G, and you need a G between the M's. So this is also not the answer. So the answer to this question is A. Question number 17, the last question of the set. Question number 17, it says, which one of the following must be true about A's schedule of voyages? Here's our diagram once again. Okay, now if you have four options, okay, and it says that out of these four options, one must be true, it means that the other three could be false. That's what it means, right? So we're going to ask ourselves the question for each one of the options. Hey, could this be false? We're going to ask ourselves this question. Okay? Now for three of the options, you'll get the answer as yes. For one of the options, you will get the answer as no. And the one that you get the no for is the correct answer. Okay? So let's go for this now, and we'll see if, any of these could be false. We'll ask if each of these could be false, and let's go for it, and we'll get our answer from there. All right. So it says that A makes a voyage to G either in week 1 or in week 2. Now I'm asking myself, hey, can this be false? So can I put G somewhere which is not in week 1 or week 2? So let me not put G here. Let me not put G here. Is it possible for me to put G here? Let me ask myself this. Okay. And when I put G here, I can see that, hey, it works quite okay. I put a G here, and then I put an M here, and I put an M here, I put a G here, and I put a G here. This works quite okay, right? You can see that it works. So yes, it could be false because I put a G in position number 3, in week number 3, which means that it does not have to be in week 1 or 2, okay? So like that, you have to pick the options and see as to whether they could be false. Now, an interesting thing, when you look at option B, for example, so A is not the answer. Look at B, it says you put M in either week 2 or week 3. So let me try to put here the M maybe in week 1. Let me put M in week 1. In fact, we just did that. I just showed you you can have the M here. Okay, put a J here, put a G here, and put an M here, put a G here, and then you can put a T in here. This works absolutely okay, so B is not the answer. Now, the interesting thing, like I was saying, is that at the most 2 voyages to G and at the most 2 voyages to J. Now, what does this mean? It says that you can have either 0, no, you cannot have 0, but you can have either 1 or 2 voyages to G. That's what this says. At the most 2 means that you have either 1 or 2, but not more than 2. That's what it means, at the most 2. So since I'm trying to ask myself, hey, could this be false? I'm going to ask myself, hey, is it possible for me to have 3 of these? Can I have 3 G's? Can I have 3 J's? Now, there's a difference between the G and the J, and this is where you get the answer, okay? Look, when you have 3 G's, it means you can have 3 G's. You can put them anywhere. You can put them here. You can maybe put a J and a G here, and then you can put an M, you can put an M, and then you can put a G in here. So you can have 3 G's quite easily, right? As you can see here. So you can put 3 G's, and so you know that C is not the answer. Now what's the thing with J? When you look at 3 J's, the problem is that the moment you have 3 J's, okay, it means that you also have 3 G's. You get it? Because J always comes along with G. So if you have 3 J's, it means you also get 3 G's free, right? It's kind of like you have J, you get the 3 G's alongside. Now, think of it like this. You have a total of 7 positions, okay? Out of those 7 positions, 6 are J and G. 1 is T. That's a total of 7. So that means there is no place left for M. Where do you put M? There's no place left for M. So that's why this cannot be true, right? When you try to see if, when you try to put 3 J's, right? When you try to put 3 J's, you can see that, hey, it doesn't work out. You cannot have 3 J's, which means that it has to be true that you can have at the most 2 J's, right? Because the moment you get a third J, it doesn't work. So the answer is this, because you cannot have more than 2. Okay, so the answer is D.